பூச்சூடி உன்னை மவுண்ட் பிரீஸ் பாடசாலைக்கு போவென்று சொன்னாலும் நன்னை தலைவாரி பூச்சூடி உன்னை.
Good morning students. In our previous session we saw about sets, Cartesian product of the sets, relations and functions, and what are the ways we can represent a function in. We saw clearly and neatly. Here we are going to discuss about types of the functions. We have four types of functions: one-to-one function, many-to-one function, on-to function and into function. Okay. First one-to-one function. One-to-one function, a function f from a to b is called one-to-one function if a distinct element in a, that means every element in a have a image in the second set b. That is given here. If distinct element in A have distinct images in B. For example, here the set A consider the elements 1, 2, 3, and in set B have P, Q, or S, and the relation from 1 to P, 2 to Q, 3 to S. Like this, sets or functions are called one-to-one function. This function is also known as injection. And then second one, a many-to-one function. So many-to-one function, a function f from a to b is called many-to-one function. Just only one difference between one-to-one function and many-to-one function. In one-to-one function, every element in a have only one image in b, but many-to-one function, many elements have same image in B. That is many-to-one function. And then like that 1, 2 have same image A, 3, 4 C and 5 D. This is many-to-one function. Many-to-one function is not equal to one-to-one function. That is entirely different from one-to-one function. And then third one, on-to function. Third one, on-to function. A function f from a to b is called on-to function if the range of a is equal to its codomain. That means every element in a have distinct images in b. That is number of elements in a equal to number of elements in b. That is on-to function. And then finally fourth one, into function. Into function, a function if there exists at least one element in B have not the image of any element in A. At least one of the element. Here we saw one example. 2 didn't have any element related to A. So that is called into function. So that is range of F is a proper subset of the codomain. So this one is domain. You know that first set is domain and the second set is codomain. So codomain, the range means number of relations in first set to second set. Here 1, 2, 3. Here also 1, 2, 3. But 1, 3, 4. These are the numbers here. These are the range of the second set. So it is proper subset of the codomain. So that one is called into function. And then bijection. So bijection means a function which satisfies both one-to-one and on-to. A function which satisfies both one-to-one and on-to is called bijection. And then special cases of types of functions: constant function, identity function, and real value function. Next, special cases of function: constant function, identity function, and real value function. So constant function, a function f from a to b is called constant function if the range of f contains only one element. Range of f contains only one element is called constant function. We saw here 6 is the only range of the function a. So this one is called constant function. Next one, identity function. A function f from a to a is defined. We can define this one: f of x equal to x for all values of x belongs to a is called an identity function on a. It is denoted by, identity function is denoted by I suffix a, that is I of a is called identity function of a. For example, constant function only one range, identity function what is image, that is equal to its domain, that is range equal to domain. So that is called identity function. X, y, z. So it is related to x, directly related to y, directly related to z. So these types of functions are called identity function. The third one, real value function. So real value function, a function f from a to b is called real value function. The range of f is a subset of real numbers, or the range of f is a subset of the real numbers, or that is f of a is a subset of, or f of a is a subset of, or that is real value function. Next one, horizontal line test and vertical line test. First, vertical line test. Vertical line test is nothing but we can draw a curve in a graphical sheet. In a graph, we can draw a curve that intersect only at most one point. That is, intersect only one point. You can draw any vertical line at most only one point is called a function, that is vertical line test. A curve drawn in a graph. You can draw a curve in a graph. You can draw a curve which is horizontal line and vertical line. So vertical line and horizontal line. Which is vertical line? So vertical line y axis, horizontal line x axis. can draw a line parallel to y-axis which intersects any one point only. That means at least one point is called a function. Like that same horizontal line test. Horizontal line test. So here we can draw one line parallel to x-axis that intersects at most only one point is called a function. Otherwise that curve is not form a function. Sorry. So you have 4 questions in your exercise 1.4. The first question, given 4 figures in your book. So you determine whether the graph given below represents a function. Give your reason. So you can write your own reason. That is, you can draw any one of the lines, both horizontal or vertical lines, and then write your answer. Now go to the second question. Exercise 1.4, question number 2. Okay, given f from a to b, f of x equal to x by 2 minus 1, and the set a 2, 4, 6, 10, 12, and in set b 0, 1, 2, 5, so 1, 2, 4, 5 and 9. So represent this function in a following. First one, set of ordered rows. Before that, we can replace the values of a in the given function f of x, because we have 1, 2, 3, 4, 5 elements in a, and we have 1, 2, 3, 4, 5, 6 elements in b. So we can replace f of x equal to x by 2 minus 1. In place of x, we replace what are the elements in a. So first one, f of 2, 2 by 2 minus 1. So 2 by 2 we get 1, 1 minus 1 is equal to 0. And then second one, f of 4, 4 by 2 minus 1, 4 by 2 we get 2, 2 minus 1 is equal to 1. F of 6, 6 by 2 minus 1 is equal to 3 minus 1, that is equal to 2. And then f of 10 is equal to 10 by 2 minus 1 is equal to 5 minus 1 is equal to 4. And then f of 12 by 2 minus 1 is equal to 6 minus 1, that is equal to 5. So you can write here 2, 0, 4, 1, 6, 2, 10, 4 and 12, 5. Now represent this function in first one, set of ordered rows. Set of ordered rows, we can write the given function f of x is equal to, otherwise you can write f only, that's enough. F of x equal to x by 2 minus 1. Write the set of ordered pairs 2 comma 0, otherwise you can 2 comma 0, 4 comma 1, 6 comma 2, 10 comma 4 and 12 comma 5. That's all. This is set of ordered pairs. And then second one, a table. So just you can form a small table. X, f of x. It means what are the elements we replace in x right here? 2, 4, 6, 10 and 12. What are the values we get here? 0, 1, 2, 4, 5. That's all. And the third one, an arrow diagram. An arrow diagram. You can draw the arrow diagram. Here only we have some different arrow diagram. I draw here. In arrow diagram, we can write what are the elements given in the questions. In set A, given 2, 4, 6, 10 and 12. In set B, given 0, 1, 2, 0, 1, 2, 4, 5 and 9. So now we can mark in arrow symbol for what is the relation. So x 2 to 0, 4 to 1, 6 to 2, 10 to 5, so 10 to 4 and 12 to 5. So we mentioned here what is the type of function. So it is 1-to-1 function. And then finally represent a graph. So we can draw a graph roughly. Just plot the points. x2 y0 2 comma 0 and then 4 comma 1 6 comma 2 not in 8 10 comma 4 and 12 comma 5. That's all. So this is a representation of a function. First one, set of ordered pairs. Second one, table. The third one, an arrow diagram. Finally, graph. Okay, can you understand? Okay. Now go to the next question. Question number 3, the same exercise 1.4. Given the function directly 1, 2, 2, 2, 3, 2, 4, 3 and 5, 4. So represent this function also an arrow diagram. A table form and a graph. So represent this function. That is given directly the set of ordered pairs here. So you can write table form, arrow diagram and graph. So you can do this one yourself. Now I go to the next question, fourth question. Question number 4, f from n to n defined by f of x is equal to 2x minus 1. Show that the function is 1 to 1 but not on 2. So we can prove this one. The function is given n to n. The first set is also natural numbers. Second set also is a set of all natural numbers. But we can prove this one. It is 1 to 1 function but not on 2 function. Okay. So what are the natural numbers? So natural numbers starts with 0 or 1. Okay, good. Natural number starts with 1 because 0 is a whole number. So all the natural numbers with 0 is called whole number. Okay. So except 0, all the positive numbers are called natural numbers, like 1, 2, 3, 4 and so on. So we can replace, that's 4 numbers, 4 or 5 numbers, that's enough because there is no n for natural number. So we can check that, that's only. Okay, here first f of x is given 2x minus 1. So in place of x, we replace the values. So f of 1 minus 1 is equal to 2 minus 1 equal to 1. F of 2 is equal to 2 into 2 minus 1 is equal to 4 minus 1, 3. F of 3, 2 into 3, 6 minus 1 is equal to 5. That's enough and so on continuously it's go. So we can draw an arrow diagram for this one. And draw an arrow diagram. So number of elements in the first set is also natural numbers. Second set also natural numbers. The function is given f of x is equal to 2x minus 1. Why repeated dot line here means natural numbers, there is no n, so we cannot stop up to 5 or 4. We can put some dots for the numbers, not n. Okay. So in place of x we replace 1 means its range is also equal to 1 and 2, 3, 5 like that and so on. So it is one to one function. How it is one to one function? What is the type of function? That is the question. Prove that it is one to one but not on to. Why it is not on to function? But not on to, because even numbers in codomain, what? Even numbers in codomain there is no distinct element in its domain. So even numbers in codomain, that is 2, 4, 6 like that, because 2, 4, 6 and so on doesn't have pre-images in domain. So it is not on to. Can you understand, students? Okay. So like that, question number 5 you can do as same. So just only one difference. The function is only different. That is f of x equal to, all the others are same. F of x equal to m square, f of x equal to m square plus m plus 3. Here f of m, given the function f of m. So in place of m, you replace the values of natural numbers, because here we have a quadratic equation, so we can replace here f of 1 equal to 1 square plus 1 plus 3, that is equal to 5, and then f of 2 square plus 2 plus 3, that is equal to 2 square value 4 plus 2 plus 3 5, that is equal to 9. Like that it's also, and so on. 3 square plus 3 plus 3, 9 plus 6 is equal to 15. It's also, and so on. So you can draw on arrow diagram. A, B, f of m equal to m square plus m plus 3, 1, 2, 3, 4 and so on. So not A, B, even n to n only. You can write n to n. Here also 1, 2 and so on, 5 and so on, 9 and so on, 15 and so on. So 1 to 5, 2 to 9, 3 to 15 and so on. So it is one to one function. It is one to one function. That's all. Okay. Can you do changes the function, means you can write it is one to one or not one to one. or onto function or into function? Can you do that? Okay. Next question number 6. Given a equal to 1, 2, 3, 4 and b equal to set of all natural numbers, f of x equal to x cube. And then what's the question? Find the range of the function and then identify the type of function. So first find f of 1. Replace the values of x 1, 2, 3, 4 and then finally you can draw an arrow diagram, write the type of function. So f of 1 is equal to 1 cube equal to 1 and then f of 2 cube equal to 8. f of 3 cube equal to 27. f of 4 cube its value 64. So range means what are the values we replace the given domain, we get in its codomain called range, that is second set elements. So we have here 1, 8, 27 and 64. These are all the range. So 1, 8, 27, 64 only have here. So type of function, you can say it directly without using an arrow diagram, but you can draw it roughly here. Set A and set B. One, two, three, 4. So 1 to 1, 2 to 8, 3 to 27 and 4 to 64. What's the type of this function? Type of this function. So in every element in A have a distinct element in B. What is its type? So good. It's 1 to 1 function. That's all. So seventh question you can do as homework. Just given two questions that which of the following is bijective or not, write your own answer. You can write your own answer. Okay, now I go to next question, eighth question. Eighth question, given set A minus 1, 1 in set B 0, 2 is bijective function. Is bijective function, that is function is given f of x equal to ax plus b, f of x equal to ax plus b, it is, sorry, not bijective, it is onto function. So onto function means these two are equal. So f of a equal to b, given f of x is onto, therefore f of minus 1 is equal to 0. This implies a into minus 1 plus b equal to 0, a minus b is equal to 0, a minus a plus b equal to 0. This implies a equal to b. Also second one, f of 1 is equal to 2, that is a into 1 plus b is equal to 2. We find here a equal to b, So replace in place of B or A, anyone change it. So A plus A is equal to 2. 2A is equal to 2. What is the value of A? 2 divided by 2, that is equal to 1. So A equal to 1. Also, what is the value of B? Because A equal to B we find here. So replace here. Otherwise we can mark this is equation number 1. Substitute here like that. We cannot use that method. So we can use that's enough. So 2 by 2 that is equal to 1. So A equal to 1. So the value of B is also equal to 1.